In this video, I'd like to show you the derivatives of the remaining trig functions. So what we have so far is that we've shown that the derivative of sine with respect to theta is cosine. Okay, so that's one. Let's box that guy off. So that's how we get sine. So I'm gonna write that up here in a different color. So if we want to differentiate sine with respect to theta, we get cosine of theta. If we want to differentiate cosine of theta with respect to the variable theta, then we get negative sine theta. Okay, so we've got those two. Now what we're missing is tangent, clearly, and then the reciprocal functions. So we're looking at secant, cosecant, and cotangent. So let's go ahead and get those. Okay, so we got these two up here. So how do we find the derivative of tangent with respect to theta? Well, what we're going to do is we're going to rewrite tangent as sine and cosine. So we know that for all values theta, tangent theta is equal to sine theta over cosine theta. So we'll make that substitution there. Now this right here, to differentiate, requires the chain rule. Excuse me, the quotient rule. So this is the bottom, the low, times the derivative of the top, d high, minus the top, times the derivative of the bottom, over the bottom squared. So this will be cosine theta times cosine theta. So d theta of sine theta, cosine theta. So put that guy in there. And then this will be sine theta times, now d theta of cosine theta is negative sine theta. So we've got, that's multiplication, so we've got negative times negative, so it's positive. I guess I'll put this guy over cosine squared. So the first part is cosine squared theta, that's this. Negative times negative is positive, so plus sine squared theta over cosine squared theta. And so we know that for any value theta, sine squared of that angle plus cosine of that angle is equal to 1. So this is equal to 1 over cosine squared theta. And we know that this is 1 over cosine theta times 1 over cosine theta. And 1 over, let's do right over here so it's below it. 1 over cosine is secant. And secant times secant, of course, is secant squared theta. So what we've got, let's just go right here. What we have is d tangent theta d theta. So the derivative of tangent theta with respect to theta is equal to the secant squared of theta. Okay, so there's our, so now every time you take the derivative of tangent, you know it's equal to secant squared. Okay, let's erase this. And now we've got to do, in a very similar manner, we're going to do the reciprocal trig functions. So let's say, for example, we want, let's do let's do cosecant. So the derivative of cosecant with respect of cosecant theta with respect to theta. Let's see what this guy's equal to. So cosecant is 1 over sine. So what we want is d d theta of cosecant theta. That's equal to d d theta of 1 over sine theta. Now let's use our quotient rule. So it's the bottom times the derivative of the top, which is 0, minus the top times the derivative of the bottom, over the bottom squared. So d d theta of sine goes to cosine, so this will be negative cosine theta over sine squared theta. And so that'll be negative cosine over sine times 1 over cosine, or 1 over sine. So this splits into negative cosine over sine times 1 over sine. So cosine over sine is cotangent, and 1 over sine is cosecant. So there, right here, is the derivative of cosecant. It's a little bit longer. It's not as nice to remember as these. But there it is. Okay, so let's keep going. We've got 2 more left. So the next one I want is d theta. We'll center this, it looks better. And let's do secant. Let's put it in the colors. Okay. So again, secant is 1 over cosine. So what we really want is d theta of 1 over cosine. So that's going to be the derivative of the top times the bottom, which is 0, minus the top times the derivative of the bottom, over the bottom squared. So the derivative of cosine is negative sine, so I'm going to have positive, because it's going to be negative times a negative, so positive sine over cosine squared. That's going to be sine over cosine times 1 over cosine, like that. So sine over cosine is tangent. 1 over cosine is secant. Just like that. Okay, so we've gotten 5 out of the 6 now. 1 more left. So we want to know what is d theta of cotangent. How do you differentiate the cotangent function? Well, d theta of cotangent is the same as d theta of 1, oops, not 1 over, of cosine over sine. So this is the low, d high, minus the high, d low, all over the low squared. So this is going to be sine theta times negative sine theta, because the derivative of theta with respect, the derivative of cosine theta with respect to theta is negative sine theta. This is going to be cosine theta times cosine theta all over sine squared theta. Now what I'm going to do here is, because this is going to be negative sine squared, this would be minus cosine squared. So I have negative sine squared theta minus cosine squared theta all over sine squared theta. So I'm going to factor out a negative 1 out of the top, and what that gives me is sine squared theta plus cosine squared theta over sine squared theta. So sine squared plus cosine squared is 1, so this is 1 over sine squared theta, and that's equal to negative cosecant squared theta, just like that. So this is equal to negative cosecant squared theta. Now you've got all 4 of your derivatives for your trigonometric, all 6 derivatives of the trigonometric function. So we've got sine, cosine, tangent, cosecant, secant, and cotangent.